Welcome to the notes on similarity. These are following the notes on dilations, but you don't need the notes on dilations in order to understand these notes. Now, in class, we did have bell work. I'm not going to take the time to go over this bell work as it'll be later, plus I only have a 15-minute time frame in which to record. So we're just going to move on. So similar figures are figures that have the same shape but different size. So they get bigger, they get smaller, but that's it. Now we can tell that they're similar if we have two different criteria. The first being that all of the corresponding angles are congruent. If all the angles are the same, we're good. Secondly, the lengths of the corresponding sides must be proportionate to each other. So if one side got multiplied by 2, then all the other sides should have gotten multiplied by 2. If one increased by a scale factor of 4, then all the rest should have increased by 4. If it reduced, if the scale factor was 2/3, all the scale factors should be 2/3. So let's take a look at that. So on this problem, we have two triangles that are similar. This triangle we have 35, 55, 90. This triangle we have 35, 55, 90. So all of the angles are the same. Now we just have to look at the sides. So when you pair up the sides, the key thing is to pair up sides that are corresponding. Now sides that are corresponding are just going to be smallest to smallest, biggest to biggest, so on and so forth. It's also important to know that whatever you put in the numerator is consistent. So I'm going to use the red triangle for the numerator. And I'm going to say 24, 32, and 40. That's from smallest to biggest. My denominator is going to be the purple triangle from smallest to biggest. Now, all of these fractions could be flipped as long as all of the fractions are flipped. So we have 24 divided by 15, which results in a scale factor, a ratio, I should say, of 1.6. This one will come out 1.6. This one will come out 1.6. So they all are proportionate to each other. That then allows me to write it as a similarity sentence, which states that triangle SUP is similar to triangle BIZ. Now the only important thing here is to note that the order of the letters matter. For instance, since S came first and S is the 35-degree angle, then B had to come first because it's the 35-degree angle, and so on and so forth. So, are the following rectangles similar? The answer to this question is no. Why not? Well, when I go to do my proportions, 25 over 18 does not equal 45 over 36. Type it in the calculator. Find out. Let's take a look at this one. Are these similar? Yes, they are. I've got two angles that are the same as two angles over here. Now, I don't need to know the third angle because in a triangle, all three angles equal 180 degrees. So as long as I know two of them, third one falls into place. I'll also notice that 8, 15, and 17, when multiplied by 2, results in 16, 30, and 34. Or 16, 30, and 34 when divided by 2 or multiplied by 1/2 gives me 8, 15, and 17. So these are in fact similar. So now the question is, how would you write it? Well, again, it all based off of order. Since K comes first and K is 60 degrees, I need the 60 degrees to come first over here, and thus the correct answer is B. Since K is 60 degrees, O is 60 degrees. R is the 90-degree angle, the missing angle, you could say, and T. Y is 30, P is 30. Now, if you already know they're similar, but yet you were missing one of the sides, you can set up a proportion in order to solve these. Now let me remind you, I'm going to go through this pretty quickly, so feel free to pause as you need to copy things down. So if I have these two triangles that are already similar, I've already told you that in this statement, I want to find X and Y. I've got all three sides of this triangle. Now I want all three sides of this triangle. So let's do x. X, which is represented by LE. Now if I look at my similarity statement, L and E are the first two letters. So that means they match up with the first two letters over here, C and O. C and O is 28. Y, I don't know, but it's LX. That's the first and the third. First and third over here is C and R. That's 35. The 54 matches up with the remaining side of 42. Again, E and X, last two, O and R. So I can pair these up, each with the 54 over 42 to solve. So let's do X first. X over 28 equals 54 over 42. Again, I'm able to do this because I already know they're similar, which means I already know their proportions are equal. I just got to figure out what that X was that caused them to be equal. Cross multiply and solve. So 42x equals 28 times 54 is 1512, and so x equals 36. I can do it again with y. Y over 35 is equal to the 54 over 42. Now, note, since I now know that this is 36 over 28, I could do the same thing. I could make this equal to 36 over 28. It's going to give me the same answer. Cross multiply, and I get 42y equals 35 times 54, gives me 1890. Divide by the 42, and I find out that y equals 45. And so everything is proportionate. These triangles are similar, and that was the values that made it so. Let's look at a word problem. So a 36-inch yardstick, yes I know, casts a 21-foot shadow. So how tall is a building whose shadow is 168 feet? And through the magic of editing, I have an example. So here's the sun. The sun is casting down its light. On the building, it casts a 168-foot shadow. On the yardstick, which is 3 feet, I needed to convert the 36 inches into 3 feet. That way all of my units were the same. Cast a 21-foot shadow. And now I can solve the problem. So if I say that the height of the stick is paired up with the height of the building, and the length of the stick shadow would pair up with the length of the building shadow, I have my proportion. So now cross multiply, I would get 21x equals 168 times 3 is 504. Then divide by the 21, and x would equal 24. Again, cross multiply, divide, answer, and that is in feet. So this building is 24 feet tall. So it's really like a 2-story building. Now, here's another problem. In this problem, Jimmy wants to enlarge a triangle with sides 3, 6, and 6 inches. If the shortest side of the new triangle is 13 inches, how long will the other two be? Now again, remember, in proportions, it does not matter what the numerator and the denominator represent as long as they're consistent. So I'm going to make the numerator my original triangle and the denominator my new triangle. The original triangle had sides of 3, 6, and another 6, but I don't need to know both of them. It's all the same. It's an isosceles. The shortest side of the new triangle is 13. Well, again, short will go with short. So that's 13. So what I'm trying to find is this side. Cross multiply. That lets me know that 3x equals 13 times 6 is 78. Divide by 3, and x equals 26. So the other two sides would both be 26 inches. Now let's talk about similarity theorems. Now, similarity theorems will only work with triangles. Okay? Can't use these on any other shape. Now the next 3 slides are just informational. Again, I only have a 15-minute time frame, so I'm going to flip through them quickly. You can pause and copy them down. So angle-angle similarity are when you know that 2 angles of 2 different triangles are congruent. You don't have to know the third because, again, in triangles, once you know 2, everything else falls into place. Side-side-side similarity says you know all 3 sides. All you have to do is fraction them out, make sure that they all equal the same thing. Side-angle-side similarity is which you only know 2 of the sides and they are proportionate, but you also know the angle between those are congruent. Now, let's determine if these are similar. Of course they are. They have congruent angles. This angle and this angle, this angle and this angle. I don't need to know about the sides. Yes, I could proportionate out the sides and find out this is also side-side-side similarity, but once you got angle-angle, done. Now, this one's going to involve a little bit of extra work. I only have 2 sides, and I only have 1 angle, but luckily it's a right angle, which means these are right triangles, which means if I want to know what the third side is, I can use the Pythagorean theorem. A squared plus b squared equals c squared. So, real quick, movie magic. Now, I have shown how I did the Pythagorean theorem to find this 24. For the sake of time, I didn't show this one, but it's all the same. So now that I have all of these, I can set up the proportions. Again, blue over red or red over blue, just stay consistent across your 3. Find the proportions and you will find out that these are similar with side-side-side similarity. This one, same thing. I'm not going to go through it because of time. Side-side-side similarity, check them. You'll find out that they all equal 3 or they all equal 1/3 depending on whether you put which triangle on top of which. This one is similar because since they are isosceles, that means if this angle pairs up with that 8, there is a matching angle over here that pairs up. Same thing with the 5s. If this angle pairs up with that 5, then there's a matching angle. Bam, 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 bam. Angle, angle similarity. Here is a Plicker question that you had in class. Now, I'm going to go through this really quickly. We can eliminate this one because it's not even possible. Now, here's the other thing, folks. I don't know anything about sides. That should automatically lead me to angle, angle. Let me show you why. Since these 2 are parallel, I have corresponding angles here and corresponding angles here. We could even throw in the fact that this angle, angle C, is shared, which means, according to the reflexive property, it's there as well. Now, who's correct? Well, Lois is. Why? Because Lois is the only one that kept the white triangle on top and the red on the bottom. Whereas Cat went white on top here, but red on top here. Alright, let's do a proof. We're going to do this really quick because my time is almost up. What's given? Well, what is given is that AL is parallel to DY. Angle 1 and angle 2 are congruent. The reason being is because they are corresponding. I know that angle I is congruent to itself because it is shared, thus the reflexive property, which means if these angles are congruent and this angle is the same for itself, that's all I need to know angle, angle similarity. Again, feel free to pause the video. This is the last bit of information. Feel free to just copy it down. And of course, it all comes down to just practice, practice, practice. If you have any questions, hit me up on Canvas.